So now today we will study about the history of the blockchain. So from where it has started and from which year it started. So and still what are all the other things that motivated this blockchain technology to come into existence. All these things we will study today. Okay. So early in the PPT, it may not be very clear, but you can listen. The wordings are not much clear here. So actually this distributed computing, it has started since 1990 itself. Okay. So we have seen that in the distributed computing platform, the several nodes are connected and they share the information. But there are a few problems in the distributed system. And in 2009, a person called Satoshi Nakamoto, okay, this person has initiated the concept of this Bitcoin, okay, and from there, this blockchain technology has also come. So usually, first the technology will come, then its applications will come. But here the thing is, first the practical implementation of this cryptocurrency, that is the Bitcoin, came into existence. From that, this blockchain technology has improved. Okay, and so slowly it has started its inventions, and from 2011 to 12, the this cryptocurrency has been deployed and it has started its usage, and then slowly the currency transfer has moved from cash transfer to this kind of digital transactions. Okay, and after that, slowly these smart contracts and other blockchain hyperledger, all these things were growing in this blockchain technology. Okay, and this is also another similar picture. So 2018, the Satoshi Nakamoto, okay, this person has brought a paper. He has written a paper in the title Bitcoin, a peer-to-peer electronic cash system. So this is what we are going to discuss today. So apart from this distributed systems, we need to know some other things related to electronic cash system, e-cash system. Okay, so because these are all aiding the new technology to come up. Okay, this Bitcoin and the blockchain technology to come into existence, and so this I have already told you in the previous class also. We need to understand very clearly that Bitcoin is not equivalent to blockchain. Okay, Bitcoin is only an application of blockchain technology. But what happened is, as I told you, Bitcoin has been implemented first. Okay, and from that, this blockchain technology has got its shape. Okay, so this blockchain was introduced with the invention of Bitcoin. Okay, so Bitcoin was first introduced as a cryptocurrency, and from that, this blockchain technology has come. So so why we are referring to this Bitcoin is that without this, the history of blockchain is not complete. So only after the practical implementation of this particular cryptocurrency called as Bitcoin, the blockchain technology has take its shape actually. Okay. So in the previous sessions, we have talked about the distributed systems, right? So similarly, now to understand this blockchain technology, we also need to know some of the things about the electronic cash. Okay, so because the Bitcoin has not come into existence in a overnight. Okay, so it has some history. So based on the previous systems, it has evolved and it has it has emerged into a new cryptocurrency. So this electronic cash it is we need to understand this. What are all the different forms of electronic cashes already available, and who has discovered that, or who has introduced that, and from that how this Bitcoin has came into existence. Okay, so we need to know all these history. And so what is this concept of electronic cash? So so we all know about previously we not only previously, now also we are using the hard cash, right? The cash amount we are holding in hand and we are using it, right? So when we use this cash, we will know the amount which is given to another person, from whom to whom it is given. So it's all known. Okay, but when we handle e-cash, electronic cash, the main problems that needs to be addressed is that accountability and the anonymity. Okay, so the thing is, we should know whether really the cash that we have transferred or made a transaction has reached the corresponding receiver or not. Okay, because in a normal cash that we are handling, it is easily known that what is the amount that we are giving and who is the sender, who is receiving. Everything is visually it is seen. But in electronic cash, when you send an amount, we do not know whether the receiver has received it properly or not. Okay, so the accountability and anonymity. Okay, so it is like anonymous. You do not know what is happening behind and so on. Okay, so that these issues has to be actually addressed in this e-cash systems. So the solution is that one particular researcher named David Chaum. Okay, so he has addressed these issues. So based on the cryptographic operations. So maybe the final years who have joined, the basic concepts of cryptography. Third years you may not know, but don't worry. We will study these cryptographic things in the later modules. So, but based on these cryptographic operations, he has brought the solutions in terms of blind signatures and secret sharing. So, what is this blind signatures? So, this allows a particular party to sign the document without even actually seeing it. Okay. So, and what is the secret sharing is that it allows the detection of using the same eCash token twice. So, what is this? What is the meaning of this? Using the same cash twice, or we can call it as double spending. See, when you use your rupees, okay, as cash, okay, hot cash, then what will you do if you have some 100 rupees and you are giving it to another person? Then you will not be, so it is transferred physically. Okay, it is transferred physically. The 100 rupees note that you are holding in your hand, it is now transferred physically to another person. So that means you will not be able to use that same 100 rupees again, because it is not in your hand now. Okay, because it is transferred to another person. You have given it to another person. So definitely you will not be able to use that same again. But in the case of electronic cash, what is the issue that is present is, it is all about transferring the like you're transferring in terms of numbers, right? You are having some maybe passports or something you have, so you are transferring it in terms of digital way. Okay, so in that case, what is the risk present is that when you have a digital currency, there is a possibility that the holder could make a copy of the digital token and send it to a merchant or another party while retaining the original. Okay, so there is a possibility in this kind of digital currency that you may make a copy of it. Okay, so what will we see in this particular picture? You can see the first picture. So you have you have some amount and you are transferring it to another person using some code or some number. Okay, so this can be copied and you can use it multiple times. Okay, so in the second picture also you can see. So he has some amount and he is using it for two different transactions, and of course it will be reaching only one person. Okay, but he is trying to spend it twice. So this kind of risk is available in this e-cash, okay, or the digital currency. So now this particular person, David Shom, he has provided some solutions so that this can be detected easily. Okay, whether a person is using the same digital token or the currency twice for spending. Okay, that can be detected. That is what secret sharing. And the next one is so following him, there are several other researchers or persons who have come out with different solutions, and they were all leading to the invention of bitcoins. Okay, so we will see some of those e-cash schemes. Okay, the first one is Chom Fiat and Now. Okay, CFN. So here they have also come up with some solutions to solve this double spending problem and the anonymity problem. Okay, so they have come out with some schemes. And the next one is brand. Okay, this person also have come up with another solution named as security reduction. So what he is trying to say here is that he has come up with a cryptographic security algorithm through which he is telling that it is hard to break that solution. So he's comparing with some other hard problem. Okay, he's comparing with some other hard problem and proving it that this algorithm that he has proposed, it is not that much easy to break it. Okay, it is not that much easy to solve it, and no one can go for such double spending things. Okay, so that is what he is coming up with. And another e-cash scheme is that Hashcash. Okay, Hashcash. So this Hashcash is one of the most important thing that is used in the Bitcoin mining process. So you will not understand what is that mining process now, but just keep it in mind this term. Okay, because we will be studying what is the process of mining in Bitcoins. So the thing is, what this Hashcash is about is that this actually who has brought it into practice has brought it for the purpose of reducing the spam emails. Okay, so you would have come across the spam emails. Okay, so when you send some legitimate mails, okay, some important mails, how many mails you will be sending for a day? Maybe maximum 4 to 5. Okay, that is how you will be sending the emails. So but whereas the if he is a spammer, okay, if he wants to send some illegitimate emails to thousands of people, he will send thousands of emails at a time. Okay, so now to avoid this kind of spam emails, what they have done is that if you are really want to send a proper email, okay, that is a legitimate email, then you need to compute a hash function. Okay, I hope you would have at least come across this hash function somewhere. Have you studied about this hash function anywhere? Yes or no?
Yes, ma'am.
Yes, right. You would have studied about the hash function. So, like some mod functions, you would have studied. So, the whatever the input that you are giving, by applying that function, you are changing your input to some other form, right? And that could not be easily read without knowing that hash key. Okay, so now this hash cache is actually introduced to avoid the spam emails. So what the legitimate user has to do is he has to compute a hash and he has to attach it along with the email, okay, as a proof that he has spent quality resources, okay, a reasonable amount of computing resources, because for finding that hash function he needs to spend a lot of computing resources, okay. This and all we will study in the later part, how why even though this Bitcoin is distributed and decentralized system, why it is so secure, okay. It is because of this hash functions, okay. So the large amount of computing resources is required to find out this hash value, and that is sent along with that email. So if he is a legitimate user and if he really wants to send that email, then definitely he will use, even if it is a high amount of resources, he will use it and get a hash function, and he will attach it along with the email and send. Okay, but if he is a spammer, he could not afford that much amount of computing resources for sending the spam emails. Okay, by that way, since it is too expensive to calculate this hash value, the spam emails will be reduced automatically. Okay, because the spammer cannot afford to have that many resources to send spam emails. So this hash cache, it is actually popularized by its use in the Bitcoin mining process. So that we will study later. Okay, and another thing is B-money. This B-money is introduced by Wei Dai in 1998. Then this is also similar to hash cache. Okay, so here also this particular person has proposed an idea of creating the money, okay, by solving computational puzzles. So actually this concept is also will come in the Bitcoin, because every time when a transaction happens, we have seen that in a distributed system, several nodes will be participating in the network, and each node or almost a majority of the nodes in the network has to agree on the transaction. Okay, that is done by doing proper validation. Okay, by doing some proper validation. For that, this hash computations will be included in that. So, and when if a particular node has verified or validated the transaction uh, at first, then that will be awarded with the Bitcoin. Okay, that will be awarded with the Bitcoin. That is, they are creating again money, because as you know, the money that we are using nowadays, okay, whether it is rupees or dollars or whatever it is, it is created by the government. Okay, we have a Reserve Bank of India, right? The Reserve Bank of India has the authority to create money. Okay, they only can create money. So that is what we used to talk about, this inflation and all things. You cannot create so much of money just like that, right? So they have some protocols, and for every year they can create newly this much amount of money and so on. So some central authority is there to create money. Okay, so so if they come up with a policy of 2000 rupees notes, then they create money for that. Okay, but now in e-cash, so similar to that, this B-money is the idea of creating the money by solving some computational puzzles. So if so in a network there are several nodes. These nodes are actually some computational resources. Okay, they are all computers. So if they solve some computational puzzles, then it will be rewarded with the money. Okay, they create the money. So that is what will happen in Bitcoins. So the same. So these are all the previous things that leads to Bitcoin. So it is based on a peer-to-peer network where each node maintains its own list of transactions. So every node will have a list or will maintain this list of transactions, and whichever node that finds this or solves this puzzle first will be able to create the money. And the next eCash scheme is that BitGold. Okay, so this BitGold, it is introduced in 2005 by Nick Szabo, and he also proposed solving computational puzzles to mint the digital currency. So what is this minting digital currency is that you can see in this you can see the thing here. So minting is defined as the computer process of validating the information, creating a new block and recording that information into the blockchain. Okay, so okay, so it is the computer process of validating the information, and by that, yesterday I have shown you a overall view of a blockchain, how the process happens, right? So when a transaction happens, like Alice has spent her amount to buy a coffee in a coffee shop, so that is a transaction. She wants to pay the amount for a coffee to the coffee shop, that is a transaction. So such transactions will be bundled in a block. Okay, that is what this blockchain is about. So now each of these transactions has to be validated. Okay, so once it is validated, it will be this information, this transaction will be recorded. Okay, so that is what actually minting. So actually this to mint the digital currency, he has introduced some concepts, again using the computational puzzles. And another thing is cryptographic currency. Okay, this is again introduced in 2005 by Hal Finney, and he has introduced this concept by combining the ideas from B-money and Hashcash. Okay, we have seen about Hashcash as well as B-money. So by combining those ideas, so what is present, what we have in B-money, there they are trying to create the money by solving the computational puzzles. In Hashcash, they try to avoid the spam emails, right? By doing some amount of by reasonable amount of computing resources, by getting a hash value, they are trying to avoid the unwanted things. So by combining these ideas, he has come up with a concept of this cryptographic currency. Okay, but in this also again it is relying on a centralized authority. Okay, so but our Bitcoin or the blockchain technology is all about decentralized thing. Okay, so it is distributed as well as decentralized, so there is no central authority to monitor over your transactions. So but here this first cryptographic currency that has introduced in 2005, it has the problem of relying on centralized authority. Okay, so all the eCash schemes that we have discussed so far, they have still they have they faced several issues based on this distributed system and this decentralization, because they are not able to come to an agreement between the nodes. Okay, there is no clear solution of disagreements between the nodes. So they have problems of disagreement between the nodes. And the second one is they still need to rely on a centralized third party. So and also a trusted timestamping. So all these problems were present in the earlier eCash schemes or the systems. So then comes this Bitcoin. So now this Bitcoin, it was introduced in 2009, and this is the first practical implementation of the cryptocurrency. Okay, so currency, you know the meaning. So cryptocurrency, what is the meaning of that? It is going to use the cryptographic operations or the principles in the currency. Okay, so all these hash operations, it's all come under this cryptographic operations. So now this is the first cryptocurrency that solved the issue of this distributed consensus. So we have already talked about consensus, right? What is the what is consensus? Coming to an agreement, okay, by almost majority of the nodes. So in a distributed system, there are several nodes in the network, and most of the nodes are honest nodes, but there are some faulty nodes as well as some malicious nodes will be there. But leaving that, if all the other honest nodes are able to come to an agreement, okay, or consensus, then that transaction can be validated. So this kind of distributed consensus they are able to implement it practically using this Bitcoin in 2009. So here this Bitcoin, it uses the public key cryptography. Maybe third years you may not know this public key cryptography. You just keep these words in mind, but we will this cryptography we will study in the later modules. Okay. So along with this Hashcash and with this public key cryptography, this Bitcoin was introduced. Okay. So what it provides is, it provides a secure and then controlled and decentralized method of minting digital currency. So it is secure and it is a decentralized method. Okay. So what is the main innovation of this in this idea is that so it is going to have the blocks, and each block will be having a set of transactions. Okay. And so as and when all the transactions in a particular block gets verified or validated, then that will be added to the blockchain. Okay. So the blockchain, it is nothing but it is a list of blocks connected with each other, and once your transaction is validated and the block in which the transaction is present is added to the blockchain, afterwards it cannot be changed at all. Okay, it cannot be changed at all. Maybe it is possible to change, but the amount of resources that you need to spend for that, it is so huge, and the hacker could not afford that kind of resource. Okay, so that is why it is very secure, and it is also a decentralized method. Okay. So this electronic cash systems and distributed systems, okay, the concepts and ideas from these two things, it is leading into the new kind of technology, that is this blockchain technology, or the implementation of Bitcoin. Okay, you can see here the eCash systems, then state machine replication, what we have studied in the previous class, consensus mechanisms. Okay, then using Hashcash, the solving of computational puzzles, then peer-to-peer networks. So all these together, with all these ideas, they have come up with the idea of this new technology, that is the blockchain technology. Okay. So now we'll look into the introduction to blockchain. So when we say blockchain, how we can define it as it is a peer-to-peer distributed ledger that is cryptographically secure, append only, immutable, and updatable only via consensus or agreement among peers. Okay. So we'll see one by one. So it is a peer-to-peer, okay, one-to-one. That means only the sender and receiver will be able to, will have the transaction connection. There is no central party or there is no third party involved in that transaction. It is only between the sender and the receiver, peer-to-peer, okay, one-to-one. And distributed ledger. I hope you would have heard of the term ledger. Okay, of course, nowadays this is very rarely used because the manual ledgers. In those days, even before the invention of computers, so in the offices they will use only the big files and ledgers. Okay, they keep on writing on that to update the transactions that has happened, okay, in the shops or in the offices. They use the ledgers. So now this distributed ledger means it is available in different nodes or different places. Okay, for example, if an institution is has some branches, or if a company has some branches, okay, so in all the branches of that company, it may be located in different cities or different geographical locations, but still it has to be the information or the data available in one location or in one office. It has to be updated in all other locations or all other offices also. Okay, but it is really a very hard thing, right? Updating in a manual ledger, and it has to be updated in all the other locations also. So, but actually this distributed ledger is, it is a database that is consensually shared and synchronized. Okay, so consensus already we know that, okay, coming to an agreement, so all should agree on that final data. Okay, so if a transaction happens in a particular location in one office, then that has to be updated in all the other offices also. Okay, for example, if they have spent some 10,000 rupees for some purpose, so their annual budget or something, it has been reduced, so now it has to be updated in all the other offices, so that they will not try to they will be thinking that, okay, this money is there, we can use it for some other purpose. Okay, so that should not happen. Every place it has to be updated. So it is a database that is consensually shared and synchronized, okay, across multiple sites, accessible by multiple people. So that is what this distributed ledger is. But now this this ledger, it is not going to be a manual thing. It is going to be a digital one, and it is cryptographically secure. Okay, so using the cryptographic functions, algorithms, it is secured. The data is secured, and it is append only. You know the meaning of append, right? So you cannot update anything in the already written data. Okay, already whatever that is, if it is a manual ledger, you can just strike it off and overwrite it. Okay, but that cannot happen in this system. Okay, as I told you, it involves a large amount of computing resources, and that is not possible that much easily. So it is cryptographically secure, append only. You can only add blocks to the blockchain, and you cannot update or you cannot delete anything from the previously added transactions or blocks in the blockchain. And it is immutable. Okay, so it is extremely hard to change, and updatable only via consensus. So even if you want to append or update, it should be happening only by agreement among all the peers in the network. Okay. So this is a network view of a blockchain given. So it is blockchain is actually, it is a layer running on top of the internet. Okay, so you would have studied about different layers, maybe, or HTTP, SMTP, FTP, and so on. This protocols you would have studied. Okay, so similarly, this blockchain is also a layer of a distributed peer-to-peer network running on top of the internet. Okay, so it is one of the layer in the network. So you can see several terms here: transactions, blocks, consensus, state machine, blockchain applications. Okay, so all these were included in this blockchain mechanism. So here we have been given a structure of a block. You can see that. So each block, it is a set of transactions. Okay, what is a block? A block is simply a collection of transactions. Okay, what is a transaction? Anything. Okay, buying a coffee from a coffee shop. Okay, so I am sending some money to the coffee shop and I am receiving the coffee in turn for that. Okay, so this is a transaction. So this is between the person and the shop owner. Okay, so it is a transaction like this. Whatever the transactions that happen, they are all bundled together and put it into a block. Okay, so we will study in more in detail about what will be the block size and how many transactions could be present in a block and so on. Okay, so now you just generally know that the block is simply a collection of transactions. Okay, and we are going to organize it in some logical way. And in so now this you can see here, the blocks are connected with each other. You can see here, right? So the blocks are connected with each other, and each block, how it is connected is, yeah, so this is the previous hash, previous block, and this is the next block. Okay, so for example, this is block number 1 and this is block number 2 and block number 3 and so on. Okay, so now in this what is present is, in block number 2 there will be a reference to block number 1. Okay, that is the hash value of this block will be present in block 2. Similarly, in block 3 the hash value of block 2 will be present here. Okay, so it is a chain. So how it is connected, how will you know that what is present before? So using the previous blocks hash. Okay, that is what given here. So the previous block's hash value will be present in the current block. And nonce we will study later. Okay, what is that nonce value? And then we have the set of transactions. Okay, so that is what given here also. So the previous previous block hash value will be present in the current thing, and the current block hash value will be present in the next block, and so on. Okay, so all these were connected to each other as a chain of blocks. Okay. And we have various technical definitions for these blockchains, because as blockchains are used in different applications, the definition also changes to some extent. Okay, so it is how we are using that. Maybe you may be using it for a financial purpose, or it may be for some other purposes this blockchain may be used. So one definition is that it is a decentralized consensus mechanism. By this time you know all these terms, I need not explain you once again. It is a decentralized consensus mechanism. Okay, so that means every node in the network has to come to an agreement for a particular transaction. And then it is a distributed shared ledger. Just now I have explained you what is the distributed ledger. So it should have a single source of truth. Okay, so all the though it is present in different locations and in different places, all the nodes should have the same kind of data. Okay, so that is what consistency we have talked about. Okay, in the CAP theorem we have studied about the consistency. The data that is present in different nodes, it should be consistent. Okay, and then it is a data structure. Blockchain is a data structure. Okay, as we have seen in the previous diagram. So it is basically a linked list. Okay, so definitely you would have studied about this linked list concept. So, and this uses hash pointers instead of normal pointers. So we have seen here there is a pointer pointing to the previous block. Okay, So based on what? Based on that previous block's hash value. Okay. So here instead of the normal pointers, we are using the hash pointers. Okay. Okay, we have some more generic elements. We will not go very deep into that because some of the terms you may not understand now. Okay, because when we study those in detail, automatically you will come across all these terminologies. So we need not bother much about these terms. Just you know the terms. That's all. Okay. So the generic elements of a blockchain, what are all the things we are going to study is this about the addresses. Okay, addresses is a main concept. So that is a unique identifier. Okay, for every transaction there will be a address, and that is unique for that particular transaction. Okay, so we need to generate an address for every new transaction every time. Okay, and so transaction, that is the main thing we keep on talking about. It is the fundamental unit of blockchain. And what is the meaning of that? Transferring some value from one address to another address. Okay. And block, again, okay, it is a collection of transactions. And we have seen some of the thing like previous block hash value, nonce. Okay, all these things we will study in detail in the later things. Peer-to-peer network. Okay, so where all these nodes or the peers can communicate with each other, and they can send and receive messages. Then this scripting or programming languages. So for transferring of this value, okay, or this tokens from one address to another address, or from one person to another person, it is basically now, if you say I am sending 100 rupees to another person, it means that I have an address and that person has an address. Person A has an address, person B has an address. So it is actually transferring from address A to address B. Okay, so for that we have some predefined set of commands in the form of transaction scripts, so that will be used for doing such transaction. Okay, so virtual machine. So again, we need not talk much about here because when it comes, we will study in detail. Ethereum virtual machine, you would have heard maybe, and because this is also not available in all the blockchains, but now it is coming up in all the things. Okay, then state machine. Okay, that is so you would have studied in your theory of computation, if maybe you are now only studying. So so finally, what is the value? Okay, on the final state, what is the transaction value, and what has to be agreed upon between each of the nodes. Okay, nodes already we have discussed much. Okay, okay, smart contracts and all we will study later. So this this is what I want to teach you today. So we have studied about the history of blockchain, the different how this Bitcoin and blockchain technology has come into existence. Okay, based on the concepts from the distributed systems and from the e-cash schemes. Combining all those concepts, they have come into existence, this Bitcoin implementation for the first cryptocurrency, and from that blockchain technology has grown. And we have seen the structure of the blockchain, the block, and different elements that is used in the blockchain. Okay, so the next chapter we will discuss in the next class. So now let me take the attendance. Kindly unmute your mic and give your attendance very fast. It's time. Okay, 38 Neela Sumant.
Present, ma'am.
Once you give the attendance, you may leave the class. Okay. Jomin Jos,
Present, ma'am.
Manoj Preetham,
Present, ma'am.
Jerome Andrew. Jerome is there. Nelson Darius. If your mic
Present.
is not working, please give your attendance quickly in the chat box at least when I call you. Nelson Darius,
Present, ma'am.
Gemini Annie,
Present, ma'am.
Sheshandri Kumari,
Present, ma'am.
Annie Cruz,
Present, ma'am.
Venkata Mukesh. Venkata Mukesh is not there. Naveen Kumar,
Yes, ma'am.
Satish Kumar,
Yes, ma'am.
Jaladi Preetham,
Present, ma'am.
Benzam Raj,
Present, ma'am.
Angeline Subakar,
Present, ma'am.
Ujjal Amitya,
Present, ma'am.
Lasvita,
Present, ma'am.
Joel Sam,
Present, ma'am.
Steve Abraham,
Present, ma'am.
Aditya,
Present, ma'am.
Bevin Jeff, Bevin, Soumya, yeah, present. Adina Sneha,
Present, ma'am.
Joseph Rajan,
Present, ma'am.
Karen Beulah,
Present, ma'am.
Christo Saharia John,
Present, ma'am.
Divina,
Present, ma'am.
Alex Kuriakos,
Present, ma'am.
Bharat,
Present, ma'am.
Ashish Kumar,
Present, ma'am.
Emmanuel Raja,
Present, ma'am.
Jabez Samuel,
Present, ma'am.
Sam Jonathan,
Present, sir.
present. Okay, Vigneshwar,
Present, ma'am.
Chinmohan
Yes,
Lal,
ma'am.
Letitia,
Present, ma'am.
Christina
Present,
Sherin,
ma'am.
Ashley,
Present, ma'am.
Hayden Rex,
Yes, ma'am.
Sriram,
Yes, ma'am. Present, ma'am.
Jemima Elizabeth, Jemima Elizabeth
ma'am.
Paul,
Present, ma'am.
Arsha Anna Daniel,
Yes, ma'am.
Rajat Nair,
Present, ma'am.
Rishabh Nair,
Present, ma'am.
Manoj Abraham,
Present, ma'am.
Bibia Susan,
Present, ma'am.
GB Thomas,
Present, ma'am.
Selvam Abhisha,
Yes, ma'am.
Abhilash,
Present, ma'am.
Don Milton,
Who's present?
Genovin Jabadas, yes, present. Darwin,
Present, ma'am.
Lamek,
Present, ma'am.
Arya Santosh,
Present, ma'am.
Sasidhar Reddy,
Present, ma'am.
Austin,
Present, ma'am.
Kambam
Present, ma'am.
Sanjay Ratna, Kevin Paulson, Kevin Paulson is not there. Sri Sai
Present, ma'am.
Rahul,
Present,
Kavin,
Present, ma'am.
Kavin,
Present, ma'am.
Singham Shetty, Singham Shetty
Present, ma'am.
Johnson,
Present, ma'am.
Sriram,
Present, ma'am.
Sriram, yes, okay. Thank you, students. You can leave the class. Thank you.
Ma'am, 18 CS 180 present, ma'am.
18 CS 180, Jerome, எங்க போனீங்க?
Ma'am, I forgot to unmute my mic, ma'am. Unmute, ma'am. I forgot to unmute, ma'am. I was
Okay,
talking
okay.
about that.
Okay, so the absentees are 18 CS 229, 19 CS 1018, 19 CS 1213.